The objective of this lesson is to use the greatest common factor of two addends to rewrite the expression as the product of a factor multiplied by the sum of the addends. This lesson requires students to see the structure of numbers and use properties of multiplication, addition, and the distributive property. This skill prepares students for concepts they will encounter in the expressions and equations strand and beyond. What is the distributive property? The distributive property refers to the idea that the sum of two or more numbers can be multiplied by a common factor. For example, when working with 12 plus 28, we can decompose 12 into 4 times 3 and 28 into 4 times 7. The result is the same, but we can rewrite this expression as 4 times 3 plus 7. The fruit juice shop is making gift bags to give away at their 5th anniversary celebration. They have 12 gift cards and 20 collectible juice mugs. Each gift bag will have identical contents. How many gift bags can be created? Let's try solving this using arrays and using the yellow cubes as the gift cards and the orange cubes as the juice mugs. We need 12 yellow cubes to represent the cards and 20 orange cubes to represent the mugs. If we filled 2 bags, we can make 2 rows of 6 gift cards and 10 juice mugs each. This could be written as 2 rows of 6 cards and 10 juice mugs, or 2 times 6 plus 10. Is there another way we could separate our cards and juice mugs but be able to fill more bags? How about 4 bags? If we build our array, we have 4 rows or bags with 3 gift cards and 5 juice mugs in each. This could be written as 4 times 3 plus 5. When common factors are removed from addends and used as a multiplier, this is called factoring. This often prompts the mathematician to factor the expression using the greatest common factor. Let's use what we learned in our previous lesson on finding the greatest common factor now to factor an expression. Mateo is setting up chairs for a concert at the park. He wants each row to be the same and as many rows as possible. There are 63 blue chairs and 36 yellow chairs. How many rows will there be? How many of each color of chair will be in each row? Write an expression to represent the situation. Let's begin by using a T-chart and find the greatest common factor for 63 and 36. The factors for 63 are 1 and 63, 3 and 21, and 7 and 9. The factors for 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. The common factors are 1, 3, and 9, with the greatest common factor being 9. If we decompose 63 and 36 with the common factor of 9, then 63 equals 9 times 7, and 36 equals 9 times 4, and can be written as 9 times 7 plus 4. To answer our problem, there will be 9 rows of chairs with 7 blue chairs and 4 yellow chairs in each row. Let's try one more. Factor the expression 45 plus 27 using the greatest common factor. Let's draw our T-chart and find the greatest common factor for 45 and 27. The factors for 45 are 1 and 45, 3 and 15, 5 and 9. The factors for 27 are 1 and 27, 3 and 9. The common factors are 1 and 9 is the greatest common factor. If we decompose 45 and 27 with the common factor of 9, then 45 equals 9 times 5, and 27 equals 9 times 3, and can be written as 9 times 5 plus 3. The objective of this lesson was to identify the greatest common factor of two addends and use the greatest common factor to rewrite the expression as the product of a factor multiplied by the sum of the addends.